This is how COVID-19 is spread. Through air currents potentially carrying microscopic droplets full of coronavirus. When we talk, breathe, or cough. We can see this thanks to when we talk, warm air streams out of our mouths, meeting the sea of colder air around us. A Schlieren setup lets us see these tiny differences. And at 250 frames per second, it shows us exactly why masks work to slow airborne infection. Now, it's important to remember that we can't see viral particles in these images. They're too small. But the viruses are carried on that breath just like a river carries fish. In fact, they fly out in droplets of moisture. Most droplets are heavy enough that they fall within 2 meters or so, but any person or object within that distance can get bathed in virus. And without a mask, some of those droplets can evaporate into super tiny particles of infection that can float on air currents far from your mouth or nose. And these micro droplets are extremely hard for any mask to filter out. But with a mask on, in the warm, humid space between your mouth and the mask, those larger droplets don't have time to evaporate, and they can be captured by common fabrics. Air currents disperse in eddies and swirls instead of flowing away in streams, which means droplets won't travel as far. What we do know is whether you're using a bandana, an N95 mask, or a cloth mask you sewed at home, they all still have a lot of droplet blocking power. But that mask has to fit. This is almost like not wearing a mask at all. A mask that's too tight or has too many thick layers can actually force more air out the sides. Here's an experiment that we did with someone talking through a sheet of laser light, illuminating all of the micro droplets released as we speak. With a mask, those droplets are all caught. And this microbiologist sneezed, sang, talked, and coughed over petri dishes. A simple mask blocked nearly all of the germs, and even though this experiment detected bacteria and not viruses, they both leave our airway in the same respiratory droplets.